welcome. Today we're going to be looking at the notes worksheet entitled Biorhythms. And I should preface this lesson by saying that the concept of biorhythms has scientifically been pretty much debunked, but I'm sure there are some people out there that ascribe to this idea, and I still believe there's also a certain novelty to looking at this as well. So we're going to investigate it a little bit today. This lesson would be a great one to work with a partner on, comparing some results and seeing what happens through the process. But I'll leave that, of course, to your discretion. So let me read what's going on here and let's give it a try. So some people believe that a person's physical, emotional, and intellectual performances occur in cycles. This discipline is called biorhythms. A person's physical stamina has a cycle or a period of 23 days, an emotional cycle of 28 days, and an intelligence cycle of 33 days. The starting point, t equals 0, is the day you were born. So apparently these cycles peak and valley over the course of these periods here, and we're going to go ahead and track yours out from today, and probably about 3 or 4 months out from today. So anyway, what we're going to have to do first, if we're going to track it from today, is we're going to have to see how many days old you are. And so letter A on your paper says, first find your t value for today. How many days old are you? So I'm going to do my numbers, show you how it's going to play out mathematically. You do your numbers, and of course, figure out your t value for today. So here we go. I'm going to bring my calculator up and pull this off. Let's see there. There we go. So I am 41 years old. So what I'm going to do initially is take 41 at the time of this posting, 41, and multiply it by 365. And so, yikes, I get that number right there. So take your age and multiply it by 365, and that was 14,965 for me. Yikes. Okay. Good. That's your first step, of course. Now we do have to account for the number of leap days that you've been alive as well, because there's an extra day every 4 years. So as it does show on your paper here, 2012 was the last leap day. So what you're going to do is just count backwards and go ahead and include the number of leap days. So for me, it was 2012, it was 2008, 2004, et cetera there, all the way back. And for me, my first leap day was back in 1972. So for a total for me of 11 leap days. Okay, so for you, again, just count it up there. How many leap days have you been alive? And include those. And then I guess the last order of business is to kind of count back to your last birthday. So for me, I'm 41 years old, and so I turned 41 in late August, and so what I want to do is kind of count back from today to late August and see how many days it's been since then. And so the day of my posting here of this particular lecture is November 30th, so I'm going to go ahead and work off the calendar that I see on your paper. And so 30 days for November, working backwards, 31 days for October, 30 days for September, and only 6 days back to my birthday in late August. And so that's the number of days since I've turned 41 to the day of this posting. And so as a result, that turns out to be, let's take a look, 97 as a result. All right, great. So I think that should account for everything here. I'm going to put a little dash right below there, and let's add everything together. So your age times 365, add the extra leap days in, and the number of days since your last birthday, and get a t value for yourself. For me, everybody, it looks to be, if I'm doing my math right there, about 15,073. Okay, excellent. I'll assume for the most part you're somewhere in the early 6,000s, give or take. So that should be your ballpark, of course. All right, that's good. Now what we're going to do is write 3 sinusoidal models for the 3 different biorhythms here, physical, emotional, and intellectual. And so as it says on your paper, we're going to go with the sine function. So I'm just going to underline that piece, everybody. We're going to use 1 as the amplitude, and then y equals 0 is the midline there. And nice and easy, pretty straightforward here. I guess so everyone on your paper, let's go ahead and get your biorhythm results. So that's going to be the dependent variable here. That's going to be our y. Amplitude is 1, so I'm just going to go right to the sine. And remember the b value, everybody. Good little quick review, of course. 2 pi over the period. So 2 pi over 23, and then times x. Excellent. Midline 0, so that's all I'm going to do. And so what you're going to see is the x value, the independent variable, is going to be the number of days, and the y is going to be your biorhythm value. And it's going to peak at +1, and it's going to valley at -1. The closer to 1, the better off you are. The closer to -1, not so much. Let's do it for the emotional here. I see the emotional has a period of 28 days, so I'm going to write it as 2 pi over 28. Obviously, guys, and you can do this on your paper, you can write it as just pi over 14 as that reduces nicely. Or, for that matter, you can go ahead and just get a decimal. That's fine as well. I'll leave it like that just so we have that complete. And then, of course, let's do the intellectual cycle. Apparently, the intellectual cycle has a period of 33 days. And so everybody, if you would, how about 2 pi over 33 times x, and there we go. So one more time, what we've done is we've written 3 biorhythm functions, sinusoidal in nature. Independent variable is the number of days since you've been born, basically. And the y value, the dependent variable, is your biorhythm value. And it's going to be anywhere from -1 up to +1. Okay, good. Well, let's track a couple things out here. You'll probably do some of the work and kind of work with this. Let's get the window first, as a matter of fact. Even before we do anything else, just kind of thinking out loud with this, let's get your window taken care of. Please make sure you're in radian mode on your calculator. And I have it sort of ascribed up at the top there as to what to do. But let's go ahead and get a window taken care of, and then that should allow us to graph these easier. So for my purposes, we're going to start from today, and for me, again, that's 15/0/73. And I figured we would go about 4 months out. This should take you probably through graduation. And so I think it just says for the x max, go with your number of days and add 120 to that. So literally, I'm just going to do exactly that, everybody. So I'm going to take my number of days, literally on the screen here, and just add 120. So this would be about 4 months out. And you can see, so I'm going to go from 15,073 days to 15,193 days. And again, what we're going to do is see this valley down at -1. So let's change that to -1 and peak up at +1. Excellent. Now, it does say to graph the physical cycle on the calculator here, so we can just get a sense of what to look for. So everybody, if you would, go to the graphing calculator and type in sine of, and then I'm going to do 2 pi divided by 23, and then that's an x if I remember correctly on this. And I might have to go back and check that, but I think that's legitimate. And so I think this was the physical, if I remember correctly. And I'm just going to hit graph at this point, and you guys do the same when you get an opportunity. And you can see, actually, sort of the situation at hand here. So first and foremost, here's sort of starting it out. Notice my biorhythm value is actually pretty high right now. That's feeling good. I should go out and run today. And then it valleys, and then it peaks, and valleys, and peaks, et cetera here. So that's what yours should look like, generally speaking. So I figure we've come up with a particular value there and see if you can trace it out and see what works. If you have some issues with the technology along the way, please don't hesitate to ask. But, ballpark it as best you can. So let me give you a couple dates, and you're going to have to do a couple calculations as to how far into the future that is. And then you'll go ahead and find a value there, your biorhythm value for that particular day. Okay, so here's what I'm thinking, everyone. I'm going to go back to your notes worksheet, and I figured just for physical, the only thing I could think of was the boulder there. So in 2013, the boulder is going to be run on May 27th. So what you're going to have to do is figure out how many days from now May 27th is, and then add that to your t value, obviously. So for example, if it's 50 days out, you don't want to look for 50 on the calculator. You want to look from today plus 50 on your calculator. So something along those lines right there. And I can show you a couple things with that as we go through, but in fact, let me grab the calculator here just as I'm thinking out loud with this, just to give you a for instance, and just in case you're wondering what's going on. So for example, what if I had, say, 50 days out? Just kind of throwing that out there. So here's what I would do. I would go second and then trace, and I'm going to hit the value button, everybody. And this is when we can give it an X, and it'll give us a Y. So I'm going to give it the number of days. And so what I said was, what if it's 50 days from now? Again, just making a number up, just keeping it easy for me. So I would literally do that right there. So my number of days right now plus 50, and then hit Enter. And so then it puts me right on the graph, and you could see, just for example, on that particular day, my biorhythm would be a little below the midline. So certainly not peaking by any means, not terrible, but not bad. So something along those lines. Okay, so you're going to have to do that for whatever day it is from now, May 27th. Okay, then everybody, you're going to graph, and I'm going to allow you to kind of take over from here. Then everybody go to the y equals and change the function now to your intelligence cycle. So remember, we wrote a function for the intelligence cycle. So, pause the video at some point and kind of go through the process here. I wrote down a couple dates. So let's see, the final exam for sophomores and juniors, let's see, would be May 20th for 5th period and May 21st for 2nd period. So 5th period and 2nd period. Sophomores and juniors, again, figure out how many days that is from now. Seniors that are taking the final there, yours would be on, let me see if I have that. Yep, there it is, May 14th. Okay, so if you're a senior, just use that date, even if you're potentially not taking the final. But check out your intelligence cycle for that day, and if you have anything else going on that you have to really get ready for, an AP exam or something like that, check it out. I certainly don't want to psych you out if it's a bad biorhythm value, but whatever. Try it out if you get an opportunity. Okay, and let's see. So you're going to do your intelligence cycle there. Again, graph it on the calculator, pick a value, and then pick the day here, and then go ahead and calculate your biorhythm value on the paper. Let's do one more. Again, just pause the video and take care of that for me if you get an opportunity. I will ask you to do one more, and this would be your emotional cycle. And I was trying to think as to what you would need to kind of have some type of emotional connection to, and graduation was the one thing I came up with. So let's see, the graduation is going to be May 18th. So even if you're not a senior, maybe you have some senior friends, are you going to be an absolute emotional wreck when they graduate, or when you graduate, or are you going to be bubbling with enthusiasm and psyched about it and so forth? Well, it all comes down, I guess, to your biorhythm value, huh? Well, anyway, let's see. Graduation's May 18th. So what you're going to do, of course, is graph your emotional cycle on the calculator there and figure out how many days into the future May 18th is from right now, and then come up with a value. So an emotional biorhythm value between -1 and +1 for that. And then the last order of business, guys, is to actually graph. And actually pause if you get an opportunity. Sorry, I'll give you an opportunity to do that emotional piece. Then come on back, and we'll do part F here, which is then to graph all 3 cycles on the same window. So you're going to graph the physical, the emotional, and the intellectual all on the same, and determine the day or days when you basically shouldn't even bother to get out of bed. So this would be when all 3 of your biorhythms are down at the valley there, close to the min. And so you'll write it as a date if you get an opportunity. I'm going to go ahead and just check mine out so you can kind of see maybe what I'm looking for and see if it works for you. All right, so let me go back to the y equals there. If I remember correctly, one of these was 2 pi over 28. So I'm going to do that. If I remember correctly, that was the emotional cycle. Again, I don't have it on my screen here. So 2 pi over 28x there. And then the intellectual one was the cycle of 33 days, so the B value is 2 pi over 33. Same deal, of course, everybody. So what we're going to do is just graph those 3 simultaneously here. I'm going to do that as well and hit graph. And what you're going to basically try to come up with is a day where really just shouldn't even bother getting out of bed. For me, it's this day right in here, give or take. It seems like they're all overlapping at the minimum. here. No, actually one good one up here. So for me, it looks like this is the day where they're all pretty bad. Over here, not so good either, to be honest. Somewhere in here, it looks like they're all kind of low. But what I would do is find one, and that's fine, just whatever you get an opportunity to do. And I'm going to go ahead and just trace that out there as best as possible and see if I can get to it. Doesn't have to be perfect by any means, guys. Again, very low-key lesson here. Just having a little fun with it. And so let's see, there it is. So 15173, and so that would be 100 days from right now. So in 100 days, I should take the day off and just relax, because that's not going to be a good day for me. So anyway, you would kind of do this and do it as a date if you get an opportunity. Track it out there. This would be the day where all three are really quite low. Again, it's tough to do kind of talking to the board here and you listening on the screen, but you know, maybe working with somebody, maybe kind of checking it out here. As I said, a novelty and probably not much more than that. Okay, guys, I would love us to do just the last piece, though. And so in this case, I do need you to be comfortable with working with the calculator and coming up with sinusoidal models for a set of data. And we've done a couple of those already, of course. So let me read example 1, and we'll try one more here. So it says the following table represents the sunrise times in Boulder, Colorado. The middle two times have been changed from daylight savings to standard time, just in order to keep everything uniform. So that would be this right here. So officially in standard time, that would be 4:32 in the morning and 5:46 in the morning. Otherwise, there would be an issue with some incompatibilities, some in standard and some in daylight. So anyway, I think this should work out pretty nicely. And again, we've talked about this before. Quantities that peak and valley and are cyclical really are sinusoidal in nature, and that's what we've been looking at. So let's give it a try here, one more. I would argue that the sunrise time depends on the day of the year. And I just picked what looks like I have 5. We needed a recurrence here on one, so I went into the next vernal equinox. That's why I went into the next year to get something. Sometimes the calculators are picky with values being sinusoidal and periodic in nature, and being able to come up with a model. You need enough data to do it. Okay, well, long story short here, guys, let's go for it. I'm going to clear my stuff out, and then I'm going to go ahead and turn my stat plot on. If I'm not using it, I tend to turn it off, but if it's on, and I will need it on in this case as I want to see everything. And so if you remember correctly, let's go to Stat and edit it. And let's get those 5 data points in, everybody. So the day of the year is going to be our X's. And make sure I have everything typed in correctly here, 4:45, so into that next year. And then this one, so it looks like I gave you those values as 6:01 a.m. So I wanted to keep it all in the uniform hours as well there. So 1 a.m. would be 1/60th of an hour. So that's where this number comes from. Okay. And looks like I'm going to have to come over here just for a moment and put a couple more in. So you guys do the same. You're probably quite a bit faster at this than I am. But let's make sure we get this taken care of. All right, those are the 2 I couldn't see. So let's drag this back on over and do the same on this last piece. And of course, repetition into the next vernal equinox there, and that's looking good. I'm going to zoom stat, so zoom and then number 9 at the top, everybody. And you could see, nice, looks good. So something like this should do, forming a sinusoidal regression for this data set. And let's go ahead and do exactly that, everybody. I'm going to hit Stat, move it over to Calc, and go up 1, of course. And there's my sinusoidal regression all the way at the bottom of this menu. I've done this before with you. If you want to go ahead and hit hit Enter at this stage, that's fine. I like hitting vars and going ahead and paste this into the y equals. So I'm going to do exactly that, everybody. I'm going to hit vars. Maybe. There we go. Move it over to the y and put it into y1. And so let's do that. And we should get our nice sinusoidal regression. Everybody, I'd encourage us to go 3 decimal places out there, if that's all right with you. I don't have a paper where this is written on, so I'll do it up here as best as I can, try to get my memory taken care of. with some of these numbers, but I saw 1.382, I believe, and then sine. Sorry, I'm going to have to keep bringing this back up. And then 0.017x. So let's see, 0.017x. And remember, just your calculator does a plus c. That's all, just so c is positive and it's a plus. So how about a plus 1.663? And so I'm going to do that right here, 0.663. And let me get that d value here. Sorry for taking my time on this. Let's see, and I've got about 5.887 on the back. So 5.887. Okay. So I didn't have it written on the paper there. That's why it took me a little time. I had to keep looking at the A, B, C, and D values. But that's good. And the idea being we've got a mathematical model for the day of the year and the sunrise time. And so I guess I'd ask you to take one step on your own here if you get an opportunity. Obviously, we would love to make a prediction out of this. So you have obviously at the top of your the front side days of the year and how many days in each month and so forth. So if you could please figure out which day of the year it is right now, write that there, plug that in for X please, and then come up with the sunrise time. And then if you get an opportunity, check that in with me, and we can look it up quickly and see how close it is. I'll bet you it's pretty sinusoidal in nature. I don't know if it's perfect, but I bet you it's pretty decent. Well, let's just take a quick peek at the graph here. I'm going to go ahead and hit graph, and a pretty good match in terms of the data set and the model. Looks good right there. How accurate it is, again, I'd be interested to see. So do the prediction if you get an opportunity, and then check in with me on that. Okay, great. So again, just low-key working with sinusoidal models before you get ready for the next assessment here. And obviously, guys, if there's just any questions or issues as you go through this lesson or any others or your work, you're going to let me know about it, please. Thanks.